Alright, so this is the lesson video for Chapter 11, Section 1. I'm going to break this lesson video up into two videos. One's going to focus on word equations, and one is going to focus on balancing equations. So, let's go ahead and get started. One thing that you'll want out during this video is a periodic table, preferably with your charges labeled across the top. And preferably your color-coded one for naming. So if you're having trouble with naming still, you may want to go back to Chapter 9 and kind of rewatch those videos. Alright, so in a chemical reaction, the reactants are written on the left and the products are written on the right. The arrow that separates them is called the yield. So reactants react to produce products. So you don't start with products, you don't end with reactants. So in this equation, hydrogen and oxygen are my reactants, water is my product. And the arrow sign is called the yield sign. So some of the things that you'll see in a chemical equation is you'll see your arrow, which is your yield sign. Sometimes you'll see a double arrow, which indicates the reaction is reversible or you've reached equilibrium. Sometimes you'll see parentheses with an S, that means solid, an L means liquid, a G means gas, and an AQ means aqueous. That's telling the state of matter of the reactants and products in that reaction. And then sometimes you'll see something written above the yield sign. That indicates a catalyst. And if you specifically see a triangle above the yield sign, that represents heat was added as a catalyst. And a catalyst is just anything that speeds up a reaction. So a catalyst is a substance that speeds up a reaction, but it's not used up in the reaction. So that's why it's not listed as a reactant or a product. So since it isn't a reactant or a product, its formula is written above the arrow in the chemical equation. So how does a catalyst speed up a reaction? Well, sometimes it gives the reactants a place to kind of meet and then bond together. It changes the mechanism of the reaction, and so it lowers what we call the activation energy. So in order for reactants to form products, they have to have a certain amount of energy to form the products. And so when you add a catalyst, that lowers the activation energy, so it makes it easier and faster for the products to form. So we're going to learn in this video how to write word equations. So to write a word equation, you write the names of the reactants and products in sentence form. So this would be an example of a chemical equation. And so all we do is we write it as if we were going to verbally say it. So H2 is hydrogen. Remember, diatomic elements, the name does not change. H2 is hydrogen, O2 is oxygen, N2 is nitrogen. All right, so we say hydrogen, and then the little g means it's in the gaseous form. So hydrogen gas. Now notice I did not say anything about the large 2 in front. The large 2 in front is called a coefficient, and it's used for balancing purposes. You could write 2 hydrogen gas if you want. Really, you would say 2 moles of hydrogen gas, but I don't focus on using the coefficients in my class. All right, so we would say hydrogen gas. Whenever you see a plus, you can just write and, or you could write reacts with. So and, O2 is a diatomic, so it's just oxygen. It says it's in the gas form, so I say oxygen gas. Once you get to your arrow, you can say react to form, yields, produces, anything you want for that. So I said react to form, and then we have H2O. Now H2O, I will allow you to just call that water. You don't have to call it dihydrogen monoxide. But I do want you to specify what state of matter it's in, because it could be in the gas form, it could be in the solid form. Okay, so I put react to form liquid water. Now, some of you may think, wow, that looks really easy, because this is an easy example. The problem is when we get to the harder ones, a lot of you are weak in naming. So if you have trouble with naming and writing formulas, as I've said before, you need to go back and watch Chapter 9 videos again. Alright, so let's look at one together. So it says, write a sentence that describes this chemical reaction. So I'm going to start with Na. Na is just sodium, and because it has an S, it's solid. So I'm going to write solid sodium. You don't have to worry about if you write solid sodium or sodium solid. Both are fine. All right, my plus, I'm going to put and then we have H2O, which is, of course, water, and it has an L, so it's in the liquid form. So I'm going to say and liquid water. All right, now I've made it to my arrow, so I can say react to form, yield, produces. This time I'll just say produces. here's where our naming comes into play. I only gave you one that's tricky on this one. So remember, you need to look at what type of element the first one is. Na is a regular metal. That means I don't need a Roman numeral. I don't need prefixes. I just name it. So Na is sodium. OH is on your polyatomic ion sheet. It's hydroxide. So it's sodium hydroxide. What type of sodium hydroxide? Aqueous. So I'm going to say produces aqueous sodium hydroxide. And then there's my plus, so I'm going to say and. Remember, if it's a diatomic, it's just its elemental name. So hydrogen, and what type of hydrogen? Gaseous hydrogen. So I'm going to put and hydrogen gas. So for these, you just don't need to become overwhelmed. Just go one part at a time. The way I grade these is I give you, like say this was a 4-point question. I give you 1 point for getting this right, 1 point for getting the liquid water, 1 point and 1 point. So I give partial credit. It's not an all or nothing. So just focus on one substance at a time when you're writing these. All right, so let's look at a couple more. Make sure you're trying some on your own now. All right, and there's my answer. I color-coded it so you can see how it all lines up. So there's your solid sodium, liquid water, aqueous sodium hydroxide, and hydrogen gas. All right, so you may want to try this one on your own. I'll pause it. You pause it. I'm going to assume you've already done it. All right, so this one we're going to go really slowly on. All right, so when I start, I say, okay, this starts with hydrogen. That means I'm going to follow my acid rules. So remember, our rules for our acids are you look at what it's bonded to. So SO4 on your polyatomic ion sheet is called sulfate. So remember, our rules for acids are 8 goes to ic. So this becomes sulfuric acid. All right, so again, if you're having trouble with that, acid naming is in section 9.4. Go back and watch that. All right, so what kind of sulfuric acid? Aqueous. So I'm going to say aqueous sulfuric acid. Now I'm at my plus, so I'm going to say and. All right, so next thing, we have BaCl2. So I look at what my first element is. It is a regular metal. All right, that means no Roman numerals, no prefixes. So it's just barium chloride. What type of barium chloride? Aqueous. So in aqueous barium chloride. All right, so I'm at my arrow. I'm going to say yields this time. So aqueous sulfuric acid and aqueous barium chloride yield. So now onto my products. So again, Ba is just a regular metal. So I'm just going to name it. So barium, SO4 is on your polyatomic ion sheet, is sulfate. So barium sulfate. What type of barium sulfate? Solid barium sulfate. So they yield solid barium sulfate. My plus, so I'm going to say and. Now we have another acid. Remember, if it starts with hydrogen, it's an acid. This is chloride. So remember, ide goes to hydroblankic acid. So it becomes hydrochloric acid. What kind of hydrochloric acid? Aqueous. So I say and aqueous hydrochloric acid. And that's it. Now, if you just saw this and were baffled by how I came up with these names, you need to go back and rewatch Chapter 9. Okay, Chapter 9 tells you how to name all of these substances. Okay, until you get a grip on Chapter 9, this is going to kick your butt. Okay, so make sure you know naming before you attempt to name 4 things in the same problem. All right, so I'm going to move on now and assume you've already got Chapter 9 down and you've already aced it and know everything there is to know about naming. Then we're going to move on. All right, so sometimes I will ask you the opposite way. I will give you the word equation and I want you to write the chemical equation. The important thing to remember on this is that you must balance charges unless you see prefixes like dinitrogen pentoxide. You don't have to balance charges. But if you don't see prefixes that tell you the subscripts, you have to balance charges. The other thing to remember is that acids will always be aqueous unless otherwise stated. So in the word equation, I might not tell you all the states that matter because I'll expect you to know some of them. When you write a word equation though, you need to always tell me the states that matter. All right, so it says hydrochloric acid. So if it ends in acid, it starts with H, which has a positive 1 charge. Hydrochloric means it came from chloride, which is Cl minus 1. Positive and negative cancel, so I don't need to cross my charges. And I told you, unless I otherwise state it, acids are aqueous. So even though it doesn't tell me it's aqueous, I know it's aqueous, so I'm going to put my little AQ. And, so I put my plus, solid sodium hydrogen carbonate. All right, so I've got to write my formula. Sodium's Na, positive 1. Hydrogen carbonate is a polyatomic ion. It'll be on your polyatomic ion sheet. It is HCO3, negative 1. Positive 1 and negative 1 cancel, so I just put my state of matter and it told me it's solid. Then it said react to produce. So that's where my arrow is. Aqueous sodium chloride. So sodium is Na with a positive 1 charge. Chloride is Cl with a negative 1 charge. Positive and negative cancel, so I just need to put my aqueous. Water, now notice it didn't say and because there's 3 products. We're going to follow grammar here. So I put and. Water, we know is H2O. If I don't specify the state of matter, you can assume it's a liquid. I'll call it water vapor or something like that if it's a gas. And carbon dioxide. So there's prefixes, so it's CO2, 1 carbon, 2 oxygens. And I didn't tell you the state of matter because, again, you should be able to assume that carbon dioxide is going to be released as a gas. All right, so again, if what I'm showing you is baffling you, you need to go back to chapter 9. You have got to get to where you can write a name, you can write a formula, you can cross charges. Do you have your periodic table labeled with your charges at the top? That would be helpful. All right, so let's look at another example. Maybe you should try the next one, see if you got it. All right, so here's my color-coded one. So here's my hydrochloric acid aqueous, my solid sodium hydrogen carbonate, my aqueous sodium chloride, my liquid water, and my carbon dioxide gas. All right, so maybe you should try this one first. Now we'll look at it together. So it says solid iron 3 hydroxide. So iron is Fe. The Roman numeral is the charge, so it has a positive 3 charge. Hydroxide is a polyatomic ion. It's OH, negative 1. So positive 3 and negative 1 do not cancel. I need to cross my 3 down, but remember, it is a polyatomic ion, so it still needs parentheses. Be very careful. A lot of you, you'll get this whole thing right, except you'll forget parentheses on that one part. All right, it is a solid, so I'll put a little S. Is heated to form. So that means it's my only reactant, so I do my arrow. Now, did you catch it? Is heated, so what do I need? I need my triangle. All right, so it is heated to form solid iron 3 oxide. So iron is Fe, the Roman numeral is the charge, oxide is O, it's in group 16, so it has a negative 2 charge. So I cross my 2 down, I cross my 3 down, and it tells me it is a solid. And water, so plus H2O. Again, if I don't specify what form, we'll assume it is liquid. All right, so again, check. If I was grading this for 4 points, you get 1 point for getting this whole thing right, 1 point for your triangle, 1 point here, and 1 point here. So how many points did you get? Hopefully you at least got 2. This is still new though. All right, and so here, just to show you my answer without all the charges and everything to confuse you, here would be our answer. And don't forget that triangle. Don't forget that triangle. All right, so like I said, if when I was showing you this, you were confused, you need to go back and watch either chapter 7, where we first learn how to cross charges, or chapter 9, where we do naming. That is very important for you to understand in chapter 11.